Starting lesson 9.1, we'll be diving into the properties of circles. All right, so we're working with what are known as central and inscribed angles. All right, the first type of angle, which is a central angle, is an angle whose vertex lies on the center of a circle. Okay, so here is our central angle. It's made up of these sides. All right, and the vertex lies on the center. All right, now the measure of the central angle, which is angle ACB, and it's what is known as the intercepted arc. This is the intercepted arc. All right. They're equal. All right, so this is 90 degrees here. So that means the arc also measures 90 degrees. And if we go to the bottom right here, this is 90 degrees, and this is 90 degrees. Notice the arc notation here. All right. The next type of angle, an inscribed angle, is an angle whose vertex lies on the edge of a circle. I used to say on, but for some students they misinterpreted that. So here's the edge of the circle. All right, and this is my inscribed angle. All right, and this is its intercepted arc. All right, now the relationship is a bit different from that of the central angle and its intercepted arc. The measure of the inscribed angle, ADB, is half the measure of its intercepted arc. Okay, so if the intercepted arc, which I have right here, is 90 degrees, that makes this 45 degrees. All right, that's what we have here. All right, there's a relationship between all of them. All right, let's do some examples now. All right, example 1, find the indicated measure and state if it is an arc, central angle, or inscribed angle. Okay, let's see, I'm working with this here. Here I have a central angle, and I'm trying to find arc AB. All right, what's the relationship between the central angle and the arc? They're both the same. That's 112 degrees. All right, so I have an arc here that I'm working with. All right, for B, let's see, they want me to find measurement of angle DFE. DFE. Okay, and now I know its measure is equal to the intercepted arc, so that's 86 degrees as well. All right, and I'm working with a central angle here. That's what I just found. All right, and for the next one, QSR. QSR. All right, the intercepted arc is 50 degrees, so this has to be 25 degrees. What type of angle is this? It's an inscribed angle. Alrighty, on to the next examples. All right, important. When an arc is described using 2 points, always refer to the shorter arc. All right, so it says WX here, so this is the shorter arc. All right, do not do this. This would be the longer arc, WX. You want to go with the shorter. Okay. All right, we're doing the same thing as before. Now I need to find WX. Okay, well, if this is 82 here, what is the arc going to be? Well, what do you do to the arc to get the inscribed angle? You cut it in half. So how do you go backwards? You double it. So this is 164 degrees. And I'm working with an arc here. All right, for part E, KML. What is KML? All right, this is 100 degrees, which means the arc is 100 degrees. All right, so here I have an inscribed angle. The arc is 100, so the inscribed angle must be 50 degrees. All right, and like I said before, I'm working with an inscribed angle. Alrighty. For part F, I have angle ACB. ACB. They want me to find that. Alright, so you're going to have to analyze this diagram a bit more than the previous ones because we have some lines that are intersecting here. Here I have this angle, which is 78 degrees. Alright, so what's the intercepted arc then? Well, what's the relationship? I take the arc, I cut it in half to get the inscribed angle. So if I want to go backwards, I have to double it. So I get 156 degrees. Alright, so this is not quite done yet. So if the arc is 156 degrees, then the central angle that I have here, which I'm looking for, that's also 156 degrees. Alright, that's a central angle. Alrighty. Then AEB. AEB, this angle here. Alright. What is that going to be? Well, its intercepted arc is right here. It's 156 degrees. So that means this angle here is 78 degrees. Got to take half of it. Alright, and this is an inscribed angle. Alright, let's go on to some more examples. Alright, example 2, find the indicated measure. KOL, angle KOL. KOL. Okay. How am I going to figure that out? Well, what is this angle right here? That's 158 degrees, right? And I have a straight line here going across. So how am I going to figure out this missing piece? I'm just going to take measurement of angle KOL plus 158, and they both add up to 180. So subtract 158, and we have measurement of angle KOL is equal to 22 degrees. All right, for the next one, arc RST, measurement of arc RST. RST. That's this whole thing here. All right, notice I have these tick marks here. Okay. So I know this angle here is 60 degrees. That's a central angle. So that means this arc here, that's 60 degrees. All right, so what can you do to figure out RST? Well, RST is essentially everything that's left over. Well, if you go around a circle, make one complete rotation, how many degrees is that? 360 degrees. All right, or you could do this. You could call this X, you could call that X. We'll do it that way. X plus 60 equals 360. All right, subtract 60 here. Have 2x equals 300. Divide by 2, and x equals 150. All right, so that's 150 degrees. That's 150 degrees. Add them both up, and I get 300 degrees. All right, then it's asking for the measurement of arc RS. RS. All right, I already figured that out. It's 150 degrees. All right. All right, on to part C. Here I have what type of angle? This is an inscribed angle. This is the intercepted arc. All right, so what's the relationship between the inscribed angle and intercepted arc? I take half of the intercepted arc, and that's what the inscribed angle is equal to. So 2x plus 1 is equal to half of 96. So 2x plus 1 equals 48. Subtract 1. 2x equals 47. Divide by 2. X is equal to 23.5. You can have decimals. It's okay. All right, on to some more examples. All right, here are a couple new properties. If a triangle is inscribed in a circle, all right, here we have a triangle inscribed in a circle, meaning the vertices are on the circle, such that one of the sides of the triangle is the diameter of the circle, so this is the diameter, then the triangle is a right triangle. All right, so that means that's a right angle. And if this is the diameter, well, this is 180 degrees here, right? And so this is your inscribed angle, which is half of the arc, so that should make sense. Inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So these angles here, they add up to 180. And these angles here add up to 180. Okay. Let's do some examples. So find the value of the variables. Okay. So here I have a triangle inside the circle. This is the diameter. So that makes this 90 degrees. All right, so I have x plus 90 plus 37 is equal to, what do all these angles add up to? It's a triangle. They add up to 180. So I subtract those two from 180, and I get 53. Done. For part B, here I have the opposite angles of a quadrilateral, which is inscribed in a circle. So I have 2a plus 2a equals 180. 4a equals 180. Divide by 4, and a is equal to 45. All right, here I have 4b. Here I have 2b. And that's equal to, they add up to 180. So I have 6b equals 180. Divide by 6. b is equal to 30. Okay. For this one, I use this property. For this one, I use this property. And for the next one, what do we have? All right, I have two inscribed angles here. And notice that they share the same arc. They have the same intercepted arc. Well, if they have the same intercepted arc, they must be equal to each other. So I have 2x plus 13 is equal to 3x. Subtract 2x, and x is equal to 13. All right, that's all there is to it. If you have any questions, please make sure to ask. Begin the assignment.